communication. I'm going to discuss one of my work. The title of this work is Machine Learning Added Tapered 4-port MIMO Antenna for V2X communication with enhanced gain and isolation. The work has been communicated in the IEEE Latin America transaction, and the paper ID is given for this work is 9 problem statement proposed solution. And the second phase, the antenna design analysis has been done, and the optimization of the antenna has been carried out with the help of the machine learning later. Third phase, the results of the antenna, the single antenna and the MIMO antenna has been discussed, and the diversity parameters of the MIMO antenna has been also included in the fourth phase. In the fifth phase, the comparative analysis of the presented work with the previous published literature has been carried out and finally been concluded. Was the everywhere around the world, everyone is focusing about the intelligent transportation system. So intelligent transportation system, to accomplish this task, we need to vehicle to everything communication. The vehicle to everything communication include all vehicle to vehicle, vehicle to infrastructure, vehicle to pedestrian, vehicle to network. All these keywords is come under vehicle to infrastructure communication. And to fulfill this task, we need a one antenna which is suitable for this vehicle to everything communication, so that it will be omnidirectional. The gain should be high, the speed should be fast, and should be reliable. The effective communication can be happened. Other than that, the key challenges before designing the antenna was that the size should be compact, the integration of the antenna. That's why we have designed the printed antenna, so that it can be integrated with another monolithic microwave integrated circuit. The gain and the radiation pattern of the antenna should be omnidirectional. That was the second challenge that we were kept in our mind. And third, the design module of the antenna, the latency should be low and the reliability should be high. That's why we have converted our single antenna into the MIMO. Project is to design a compact and high performance antenna for V2X communication that ensure reliable, high speed and secure connectivity in various environments. So in this communication, a 4-port MIMO antenna is analyzed and investigated for vehicle to everything communication, which is centered at 5.9 gigahertz. Why it is centered at 5.9 gigahertz? Because as you can see in the given PPT at table number 1, the various countries, throughout the countries, all are focusing on this frequency band, because various international telecommunication union has designated this particular band for the V2X communication, where 5.9 gigahertz is the center frequency and the band is around 70, 80, 20, 50 and 75. So our intention was to design the one antenna, those having a single band, and it is work at 5.9 gigahertz. Later, to achieve the optimum dimensional configuration, the machine learning algorithm has been used in this manual script, so that the complexity of the high frequency electromagnetic solver can be reduced, and different machine learning algorithm is used. Later, the diversity characteristic of the antenna has been simulated, and the findings are measured, and coherence is obtained, is seen between the simulated and measured. See, you can see that we have a single antenna, two-port MIMO antenna, 4-port MIMO antennas. These are the geometrical description of the layout, and their fabricated layout is presented in this diagram. Fabrication is carried out. Vector network analyzer is there, where we are calculating the scattering characteristic of the presented 4-port MIMO antenna. Port MIMO antenna, the evolution stage is in front of you, where we have included a 5-step. Our main intention was to attain the return the S11 at 5.9 gigahertz. So by observing all these steps, you can see that for step number 5, we are getting the 5.9 gigahertz S11 value of minus 3 dB. So that design is the final proposed design. Later, to finalize this design, the single antenna design, we have also used the machine learning algorithm. 4 different machine learning algorithm has been used: XGBoost, random forest, DNN, stacking, ensemble, and the comparative performance is also carried out. Which machine learning algorithm is best for the given module, and the results obtained by these all machine learning algorithm is given in terms of scattering parameters, that is S11. So you can see from this diagram that the stacking ensemble method is the best method for this discussion of the 4-port MIMO antenna. So here you can observe that the S11 characteristic of the 4-port MIMO antenna is very much similar, and the isolation is greater than 15 dB. It means all the 4-port MIMO antennas are working individually, because isolation is very high. Similarly, to further justify this findings, electric field distribution plot is in front of you, where we have energizing the each port by terminating the other port. So here you can see when we are providing the energy to each port, the energy will be confined to that particular port, and very less coupling is observed with the other port. Later, the measured findings is all presented in front of you, where the simulated and measured findings are very much close. The scattering values of simulated and measured findings are very much close. Small discrepancies there because of the human intervention. Gain, the measured gain is 7.85 dB, can be seen, and the radiation efficiency is greater than 98% can be seen in this diagram. MIMO antenna has been also calculated, where all the presented values, all the calculated values are well within defined range. It is ECC, DG, CCL, and TARC. All these values for the given presented MIMO antennas are well within the range, and each and everything is explained in detail in the manuscript. And further, to justify the novelty of the proposed MIMO antenna, the comparative analysis is performed in terms of the number of ports, entry frequency, maximum gain, radiation efficiency, isolation efficiency. As you can see, the proposed work is very well and very much optimum in terms of the gain and radiation efficiency. Isolation is very good, and the diversity characteristics is also very good, which is ACC 0.001. The presented antenna can be used for V2X communication in different countries. In the United States of America also, we can use this antenna having a 340 megahertz of bandwidth, and the structure has been very validated with the help of the different machine learning algorithm, and simulated and measured results has been in the coherence. Thank you very much.